Very good morning, dear students. Am I audible?
Yes, sir. Good morning,
Yes,
sir.
sir.
What about others? As I'm able to see only two fellow. So how many experiments we have completed in our subject? Dear students,
Three. Three, sir.
three. And what about status of file? Hello?
Yes, sir.
You can turn on your camera. 3543.
Yes, sir.
Yes, dear. Uh, what is the status of your file?
Sir, it's still pending, but we can complete in next lab due to next lab.
Okay.
Yes, sir.
Uh, I'm pasting one message in your WhatsApp group that uh, you people are supposed to complete three. Okay, no need to. You can turn off your cameras. Okay.
Yes, sir.
Basically, uh, before coming in the next laboratory, I am expecting that you people should email me first three experiments. First three experiments. Okay. And first three experiments. Okay. Let me just check the message. See, we have already completed RTD. Experiment 2 was LVDT. Experiment 3 was thermocouple. Okay, so I'm just putting one message in chat window. Okay, I have pasted one message in your chat window. Do email to me first three experiments. Okay, what you are supposed to write, that thing I would like to show you. I have shared my screen. Is it visible?
Yes, sir.
So basically, consider first experiment. You are supposed to write in your file page because probably your submission will be offline. Okay, so experiment 1, aim, objective. Instead of prerequisite, you can directly go through the theory. Okay, in theory, you can mention this kind of thing. Okay, and if any kind of graph is there, then you can mention that graph, observation table. Okay, then in procedure, if you are not going to mention each and everything in detail, see, this student has mentioned consider RTD. Okay, so in VLab simulation, it contains 2 sections. Am I right? But if you are
Yes,
not
sir.
going to write this many detail, then that is fine. You can just mention we have followed the procedure of VLab simulation steps. That kind of one statement you can mention. Okay, graph, observation table. After observation table, if any calculation is there, before observation table, you can mention some calculations. Okay, then procedure and conclusion, and over there in VLab simulation they have provided 4 to 5 questions. Okay, so you are supposed to write these 4 to 5 questions. So 35 number, hello dear, 35 number.
Yes, sir.
Is there any confusion?
No, sir.
Aim, apparatus, theory,
Yes, sir.
then
Then calculations.
calculation,
Then if graph is there,
graph, any
and
diagram is there, then
yes, sir.
okay,
Then questions
observation
and then
table,
conclusion.
then procedure,
Yes.
conclusion, and at the end 4 to 5 questions
Questions.
which are available in VLab simulation.
Okay, sir.
43 number.
Yes, sir.
Okay.
Yes, sir.
36 number.
Yes, sir.
Is there any confusion here?
No, no, sir.
So you can put this message in your WhatsApp group that sir is going to check your file. Okay, and we are supposed to write first 3 experiments. Okay.
Yes, sir.
So how was your exam?
Fine, sir.
Okay. It's a fourth lab. Is it visible?
Yes, sir. Visible.
Okay. Okay, it's a third. Okay, I need to fifth lab. PPT for initial 3 lab is already available on Microsoft Teams, so you can go through it. And one thing I would like to mention over here, your presence make some effect on your marks. Okay, so be remain present at the time of laboratory or lecture session. I have shared my screen. Is it visible?
Yes, visible.
Yes, sir.
Okay. This particular experiment is specially designed for you people to understand uh, how pulse oximeter works. Okay, pulse oximeter. Have you seen that device, pulse oximeter? Have you heard
Yes,
that
sir.
name? What it is? How it works?
So it checks our heart rate.
Okay. So one video is available over here so that I can have some base. Based on that base, I can teach you about pulse oximeter. Okay, so I'm just playing this video and then we will start understanding this device. So just have a listen, just listen this thing and how pulse oximeter works. Just go through this video.
Hello everyone, welcome to Out of the Box Reviews. Today we are talking about the oximeter. What is it and how can you use it? An oximeter is a small device that does exactly what the name implies. It measures the amount of oxygen in your bloodstream and it displays the concentration as a percentage on its screen, just like a thermometer measures body temperature. These devices have been in use for years by medical professionals in order to get a first view of a patient's condition. Luckily, technology has made it possible for all of us to own one such device at a very low cost. And given the situation the world is currently in, I believe that all households should have at least one. This particular oximeter is made out of two plastic parts that are connected with a hinge. It has a single button for all its functions and one colored LCD display. By pressing and holding the hinged part, the infrared sensor is visible. Everything is powered by two AAA batteries. Now let's take a look at how it works. By pressing the button once, the unit turns on and information appears on the screen. In this case, besides the oxygen amount, we also have a pulse meter function. By pressing the button again, you scroll through the different screen orientations available to find the one that suits you the most. The unit will turn off by itself when not in use. In order to enter the menu, you press and hold the button for 3 seconds. Here you can change the maximum and minimum accepted values for both the oxygen amount and the heart pulse. You can also customize the alarm effects of the unit. Now let's see how to use it. Using the device is very simple. Simply press the button once to turn the unit on and the sensor will start flashing. If you need to change the orientation of the screen, press the button again. And then stick your index finger in the device, making sure that the best part of your fingertip is covering the sensor. If your finger is in the correct position, you will see a representation of your pulse coming up in the screen. Try to keep still and in a few seconds the oxygen amount and your current pulse rate will appear on the screen. As I said, it's a very simple device and extremely useful for everyone. However, I must inform you that this device cannot replace the diagnosis from a real medical doctor. You should treat it just like a thermometer. It's an indication at best, not a full medical diagnosis. This was Out of the Box Reviews. Thank you all for watching, and remember to stay protected and safe out there. Thank you. Hello, everyone.
So now you people are having a little bit base about how pulse oximeter work. So by just looking that video, is there anyone who can tell me how it is working? Working principle. I'm asking you people about the working principle of pulse oximeter. You seen that video, dear students?
Yes, sir.
So just try to say about something about its functionality in your words. No worries, I'm here to help you. And definitely I will explain each and everything in detail. In my upcoming slides, I have placed those details. But just by looking that video, what you gain? "46 number."
Hello?
Yes, dear. Yes, dear.
Yes, sir.
Say something about that video.
Sir, actually, I didn't see that video because of network error.
Should I play it again?
Yes, sir.
Okay, no problem. Same question I'm going to ask you at the end of this video.
Hello, everyone. Welcome to Out of the Box Reviews. Today we are talking about the oximeter. What is it and how can you use it? An oximeter is a small device that does exactly what the name implies. It measures the amount of oxygen in your bloodstream and it displays the concentration as a percentage on its screen, just like a thermometer measures body temperature. These devices have been in use for years by medical professionals in order to get a first view of a patient's condition. Luckily, technology has made it possible for all of us to own one such device at a very low cost. And given the situation the world is currently in, I believe that all households should have at least one. This particular oximeter is made out of two plastic parts that are connected with a hinge. It has a single button for all its functions and one colored LCD display. By pressing and holding the hinged part, the infrared sensor is visible. Everything is powered by two AAA batteries. Now let's take a look at how it works. By pressing the button once, the unit turns on and information appears on the screen. In this case, besides the oxygen amount, we also have a pulse meter function. By pressing the button again, you scroll through the different screen orientations available to find the one that suits you the most. The unit will turn off by itself when not in use. In order to enter the menu, you press and hold the button for 3 seconds. Here you can set the maximum and minimum accepted values for both the oxygen amount and the heart pulse. You can also customize the alarm effects of the unit. Now let's see how to use it. Using the device is very simple. Simply press the button once to turn the unit on and the sensor will start flashing. If you need to change the orientation of the screen, press the button again. And then stick your index finger in the device, making sure that the best part of your fingertip is covering the sensor. If your finger is in the correct position, you will see a representation of your pulse coming up in the screen. Try to keep still, and in a few seconds, the oxygen amount and your current pulse rate will appear on the screen. As I said, it's a very simple device and extremely useful for everyone. However, I must inform you that this device cannot replace the diagnosis from a real medical doctor. You should treat it just like a thermometer. It's an indication at best, not a full medical diagnosis. This was Out of the Box Reviews. Thank you all for watching, and remember to stay protected and safe out there. Thank you.
Yes, dear.
Yes, sir.
Say something about it.
Hello.
Yes, dear.
Yes, sir. Pulse oximeter is used for taking reading of pulse at hospital.
Okay. But how it works? Anyone else?
Sir,
Yes, dear. 46. Continue.
sir, it has sensors of taking in hertz frequency.
Okay. 47 number.
Yes, sir.
Would you like to say something?
Yeah, sir. Actually, the pulse oximeter works by the principle that it emits infrared light, and it scans that how much percent of the light is absorbed and how much came back. And from that, it gives an assumptions of the blood oxygen.
Correct. That's true. Okay, nice one. What's your
Thank
name
you.
here?
Aniket Sharma.
Aniket. Okay. So over here today, it's our index, aim, pre-test, theory, simulator, and VLab link. Okay. So simulate the performance of biosensor. Though it is made up of electronics, but with the help of that, we are measuring or we are acquiring biomedical information. That is why it is called as a biosensor. Okay, it's a pulse measurement technique. By performing this experiment, we are going to understand the importance of pulse measurement, study the technique used for pulse measurement, and if you want to design such kind of system, pulse measurement system, then which are the challenges or which kind of precautions you should take. Okay, those things we are going to see over here. So one test is available over here. Definitely some questions are known to you. After completion of this thing, you can take this pre-test. Okay, even I have placed solution for the pre-test questions. Okay, so before performing this experiment, student must have knowledge about working of a diode and LED, light spectrum, and various factors that affect the light output of LED. Example, temperature, wavelength, etc. So what do you mean by diode? Dear students, please respond me. "38 number.
Yes, sir.
What is diode?
Diode.
Yes.
Sir. So diode are the semiconductors devices. Hello, sir.
Okay. Say something more.
So diodes are allows the current, sir. It allows the current in semiconductor.
Okay.
Yes, sir.
35 number.
Yes, sir.
Say something about diode.
Sir, it is a semiconductor device which acts as a one-way switch. We can tell actually it allows the flow of current in one direction.
Okay. And what about LED? $35 number.
Yes, sir. So LED is also a semiconductor light source, means that emits light when current flows through it.
Okay. And over here, third statement is mentioned as a just go through last three words. For example, temperature, wavelength. What it is?
I don't know, sir.
36 number. $36 number.
Yes, sir.
So effect of
Hello.
various factors that affect the output of an LED. For example, temperature, wavelength. So why? So can you justify that particular third point? $36 number.
Yes, sir.
Why temperature and wavelength affects the output of LED?
Don't.
47 number.
Yes, sir. Sir, actually, by increasing the current, the temperature will also increase, but with that, the output will decrease continuously. Means if we increase the output current for the LED, the forward voltage will also increase. So the power dissipation will also increase. So due to that, the color or the temperature will also increase. So due to that, the output color can vary accordingly.
Okay. Still some correction is required. 43 number.
Sir, the LEDs means if the LED depend on also on temperature and wavelength. If the temperature or the wavelength is varies, the LED glows, means the LED light is also vary.
In one statement, I can say like semiconductor properties of the semiconductor material gets changed due to the surrounding temperature. Even if any light falls on it, then the electrons which are available in valence band can jump into the conduction band. Okay, due to that, conductivity of the semiconductor devices or material gets changed. Okay, so over here we need to consider these two factors whenever we are going to design our device. Okay, so basically pulse rate. Pulse rate or pulse is the rate of which human heartbeat beats. Okay, so beats per minute. If we want to calculate our pulses, then its unit is beat. Okay, now basically what happens in our heart, various chambers are there. Okay, and those chambers are having different type of valves. Okay, so based on the natural mechanism, particular pressure gets created and particular valve gets open or closed, and based on that our pulses gets generated. Okay, so our pulses changes from minute to minute. It will be faster when anyone is exercising, or if one is having fever, or if a particular person is under the stress. Okay, it will be slower at resting condition. Okay, so in emergency situation, the pulse rate can help to check whether heart is pumping enough blood or not. Okay, so through which we can find the cause of symptoms such as irregular or rapid heartbeat. Okay, even drowsiness, fainting, chest pain, or shortness of the breath. It may happen. Okay, so if any kind of blockage is there, then also we can come to know by assessing the heart functionality. Okay, so now this particular thing is important for us. Okay, just have a look on the diagram. Is it visible? Are you able to
Yes,
see
sir.
the diagram? So LED is there. LED is going to generate the light. Okay, then one box is there when our human finger can be there. Okay, and then detector. Okay, detector is going to receive the light. Okay, so light intensity will change based on the blood flow through the veins. Okay, so first diagram is for the transmittance, in which LED is at bottom side and detector is at upper side. Now just have a look on the second one. Okay, where reflectance is mentioned. Okay, where LED and detector circuits are together. Okay, so LED is going to emit the light and its reflections will be collected back at the detector side. Okay, so LED and detectors are placed together through which we can collect the reflections. Okay, so reflectance probe or transmittance probe, based on which we can have data acquisition. Okay, and this particular process is called photoplethysmograph. Photoplethysmograph. Okay, so in photoplethysmograph, just have a look on this basic block diagram of instrumentation. Okay, LED is there, human finger LED, nearby LED VCC is mentioned, so it is nothing but supply is there with LED, then human finger is there. Okay, then LDR. Okay, so light dependent resistor or photodiode or phototransistor can be there. Okay, through which light will be converted into its approximate electrical signal. Okay, so CDS cell, okay, cadmium sulfide cell, or LDR or photodiode or phototransistor can be there. Okay, now next block is signal conditioning. Now, dear students, signal conditioning is very important thing over here. Why? Because the signals which gets converted with the help of photodiode, okay, that amount will be very lower. So you need to amplify those signals. Even if filtering is required, then you need to filter those signals. That is why that signal conditioning circuit is required. Signal conditioning, okay, and this entire process is called as a photoplethysmograph. Now over here, as it's an analog thing, so at the end of signal conditioning block, we will be having analog signal, okay, and then A to D conversion, particular logic. Logic means this much amount of variation in the light is equal to this much amount of number of pulses, okay, pulse per minute, ppm. Okay, so that particular entire process is called as a photoplethysmograph. And pulse oximeter works on this particular principle of photoplethysmograph. Okay, now next is design considerations. Now, first one is motion artifacts. Motion artifacts is very easy thing which one can understand very easily. Consider you are visiting doctor. At that time, what he is doing, he is taking your hand and he is telling you to put your hand on one table on flat surface, and he will say that just be steady. Okay, why? Because if you are going to move your hand or leg or any other thing, in that case muscles will get stretched. Okay, in that case blood flow gets affected. Okay, and due to that we may have incorrect results. Okay, so at the time of any biomedical signal acquisition, consider ECG, electrocardiogram, EMG, electromyogram, EEG, electrooculogram. Okay, such kind of too many signals are there. Whenever you are there, at that time you should be steady. Okay, movement is not allowed. Second is optical interference. Okay, optical interference, that is nothing but external light source. Whenever you are going to put your your finger in the pulse oximeter, at that time if outer light gets enter in the pulse oximeter, in that case your observation may get affected. Okay, so over there, such kind of environment should be there where external light is not going to enter in the case of pulse oximeter. Now, third parameter basically is it contains light dependent resistor and LED. So both are made up of semiconductor material. Okay, and properties of the semiconductor material gets changed due to the effect of the temperature. So it is expected that temperature should be stable. Okay, and effect of distance between source and sensor. So whenever you consider you are willing to design device over there, you should read datasheet carefully, and based on that you should put appropriate distance. If distance is very short, in that case also we are not going to get appropriate observation, and if that distance is long, in that case also our observations may get deviate. Okay, few advantages are there: fast operation, easy to use, accurate readings, and over there it's a non-invasive method where they are not going to take your blood or any other thing. Okay, so non-destructive technique, and it's a reliable. Basically it's a kind of instrument through which we can just measure the pulses. Okay, pulses per minute, but we cannot say anything about blood flow. Okay, for that even you need to use another method. Even we cannot say anything about presence of hemoglobin. Okay. So over here, to understand the functionality of heart, one another video is placed. Just have a look on this video.
Welcome to the Stanford 25 video on pulsus paradoxus. Pulsus paradoxus is defined as a systolic pressure drop greater than 10 with inspiration. Normally, during inspiration, the decrease in intrathoracic pressure will cause an increase in blood flow to the right side of the heart, leading to an increase in pressure transmitted to the right ventricular walls. Since more blood remains in the lungs during inspiration, a small drop in systolic blood pressure is expected. However, in tamponade, the increase in blood flow and pressure on the right ventricle during inspiration cannot be transmitted to the right ventricular wall, and is in turn transmitted to the ventricular septum. This in turn leads to a decrease in left ventricular filling, which causes a decrease in stroke volume and a much lower systolic blood pressure. To measure pulsus paradoxus, all you need is a stethoscope and a blood pressure cuff. To test for pulsus paradoxus, slowly look for the first Korsakoff sound that will appear, then disappear during inspiration. Next, slowly listen for when the first Korsakoff sound no longer disappears with inspiration. This clip was recorded from a patient at Stanford University with a pericardial effusion. Pulsus paradoxus can be a valuable clinical tool and has been shown to have a sensitivity of 98% and a specificity of 83% in predicting cardiovascular compromise. Along with tamponade, pulsus paradoxus can be seen in some patients with constrictive pericarditis, during asthma or COPD exacerbations, and less commonly in other clinical scenarios. Importantly, pulsus paradoxus may not be present despite a patient being in cardiac tamponade in certain situations such as aortic regurgitation and atrial septal defect. In addition to other findings such as an elevated jugular venous pressure, tachycardia, and shortness of breath, Pulsus paradoxus can serve to be a valuable tool in the evaluation of a patient with suspected cardiac tamponade. This has been the Stanford 25 video on Pulsus paradoxus. Thanks for watching.
Now let us move to the VLab simulation. Is there any confusion in this discussion, dear students?
No, sir.
So I have covered each and everything with the help of PPT. So I have prepared that PPT especially for you people, and I have covered each and everything. Just be connected with me. I'm getting one important call. Okay. Now just have a look on this diagram. Here, instead of human finger, what they did, they have considered one wheel, rotating wheel. On that rotating wheel at outer periphery, it is having holes. Okay, so what happens when LED is glowing at that time? Once that hole come, at that moment light will pass through that LED, that hole, and it will fall on the LDR. Okay, and then processing happens. So here in the configuration we can have, consider if I'm starting the rotation, so speed is less, okay, and we are having some observations. Now second, consider one, I'm starting it, now speed is more, even you can see this thing with the help of animation, 1 revolution per minute, okay, even I can do the reload again, start, okay, now speed is 2 revolution per minute, so I can say like within 30 seconds it is going to revolve, it is going to complete the entire rotation, okay. So you can go through this rotation, internet is little bit slower over here. Welcome Patil. Thirty-four number.
Yes, sir.
How are you?
I'm fine, sir.
So why you are too late?
Sir, I'm at my home and I'm facing some net issues. That's why I connected late. Sorry for that.
Right now I'm unable to jump to the level 2. I don't know why, because when I checked at that time level 2 was coming. So probably if you're going to try after some time.
Sir,
Yes dear?
sir, if the rotation is completed, then we can go to level 2.
Pardon?
If the rotation of the LED is completed, then we can go to level 2.
Okay, so I need to wait for an entire 1 minute. Am I right?
No, sir, 110 seconds.
Okay, 10 seconds for each observation. Okay, now level 2. Okay, so consider 12-year adult. Okay, so generally for the 12-year adult, heartbeats are in the range of 60 to 100. Consider adult athlete, so their heartbeats are 40 to 70. Okay, now level 3. I'm just considering the error. Just have a look on the finger. Consider misalignment. Okay, so if mis misalignment or stray light is there, in that case we are going to get the output error. Okay, so it is expected that we should try to minimize this thing. Okay, dear students.
Yes, sir.
So today we have learned about experiment number 4. I'm just putting that thing in a chat window. Patil. Himanshu. Himanshu,
Yes,
are you
sir.
there? In next lab, I'm going to check your files. Okay.
Sure, sir.
And remaining experiments in upcoming laboratories. Is there any confusion regarding today's laboratory, dear students?
No, sir.
No, sir.
Thank you
Sir,
for
but
joining.
I have a question.
Yes, dear.
Hello.
Sir, could you please give us a format in the way how we can write our files
It
or
is
something like
already
that?
discussed in the beginning of the laboratory. I've already
Okay.
shown them one reference file, what to write, how to
Okay.
write. Okay.
Okay, sir.
Thank you. You may leave now. Take care.
Thank you, sir.
Thank you, sir.
Okay, dear.